2023 is about to wrap up, and at the time of this recording, today is kind of a special day. So may I say happy birthday, Conor McKechnie?
Oh, you may. Thank you very much. And 2023 is about to wrap up. We've talked about a lot this year.
Yes, everything from virtual reality, CRISPR technology, phages, liquid biopsy, combination therapies, of course, serendipity,
and so much more. So it's time to share our favorite interviews and episodes of the year. Let's get straight to it. And because it's my birthday, I'm going to start.
Fair enough.
My favorite episode of the year was part 1 of the revived therapies, psychedelics. According to our Spotify Wrapped, which, comes around and tells you, great piece of clever marketing, what you've listened to and what's worked for you, this episode was actually our most shared episode.
Thank you for sharing that episode.
It was absolutely fabulous. We spoke with Professor Eric Vermetten in the Netherlands, a psychiatrist who has been working with the military there for the past 25 years, helping the armed forces and uniformed people face PTSD and using the discipline of psychotraumatology.
So can we turn to sort of talking a little bit about what you're researching? Could you describe sort of the new therapeutic areas that you're looking at? The use of drugs which have previously been used in psychiatry, but maybe not in this area, that have fallen out of favor and are now coming back to the fore, and we're seeing increased studies in the use of them.
Well, not for no reason. I said that I'm in Leiden. And in Leiden, there was a colleague psychiatrist by the name of Jan Bastiaans, who was looking, before we had PTSD, at the concentration camp syndrome. People who survived Auschwitz or the major concentration camps and survived these camps, but were tormented with these memories. And what Bastiaans did, there was pre-PTSD, he used psychedelics to intervene, to give people, quote unquote, their lives back, in order to give them a sort of verbatim, give them the ability to explore things that they have not been able to revisit after they survived the camps. So Jan Bastiaans used LSD and psilocybin and ketamine, and this was 50 years ago. And then, of course, there was the backlash that these psychedelics were kind of forbidden, and a lot of negative press about the use of psychedelics. But recently, these psychedelics, the last 10, 15 years, have shown us the potential, specifically in severe cases of PTSD. It's not in the early cases, like I just said, if it's there for half a year or so after you return from Afghanistan. No, in these really difficult, complex cases, we see that these compounds that we've known for years have great potential.
Why was that your favorite, Conor?
What I loved about it was that we had this idea many years ago that there were therapies that potentially could help in areas where there were no real therapies other than potentially talking therapies. And it's not to undermine talking therapies as a modality. And that for some reason or other, that those therapies were taken away from us. And we've seen that in other cases, not just because of legislation, but because of geopolitics, like phage therapies, the same thing. And then because the world has changed, that those therapies are now possibly back on the table. And it just gives me real hope that, as we progress and discover more and more about the human body and the human mind and how it works, that things that may already be in our repertoire, things that may already be in our arsenal, could be something that we could apply to future cases, future therapies, and so on. So that's why I really liked it. It's about bringing things that we know about, like off the shelf, dusting them off and applying them in new ways.
The solution might already be at your desk.
It is. It could be that. So what about you, Dodi? What's one of your favorites?
Well, I cannot resist a playful connection. So when a scientist grows plants coming out of his walls, for example, or creates an experiment that harkens back to the early days of computing. In March, I spoke with Dr. Brett Kagan for our Never Underestimate a Cell episode. Dr. Kagan conducted research to understand the brain and test sentient brain cells. So when do the cells actually start thinking? Now, he used the 1970s game known as Pong. Remember?
I remember Pong. It was a great game when you were like 8 years old. Less so now. But these twisty paddle things, it was frustrating but fun. So why Pong? Why pick a 50-year-old, albeit awesome computer game that is simply about making sure that you hit the ball into the right place.
So Pong has incredibly clear win or lose conditions, and Pong happens in real time. So it's not a move that you have to wait for a response to then make the subsequent move.
Okay, so that's why it's not chess or backgammon, right?
That's right, because those games are not continuous. You make a move, then you wait for your next turn. Kind of like children and dogs, it's hard to teach cells to wait for their turn.
It's like playing with your cat. Cats don't understand taking turns, and there's no reason a group of cells on a dish would either. But every simple system does learn to operate in real time. You know, flies, worms, they move around in the real world continuously. And so we needed a game where there was a close to continuous control and gameplay. And Pong fit the bill, easily recognizable. One of the first games used for machine learning, one of the first games at all. So that was why we picked it, you know. Nostalgia definitely played a role, but it also met a bunch of other criteria.
So whilst I found Pong a great pastime when I was like 8 for probably about 6 months, one of the things that I have a perpetual passion for and can never do enough of is surfing.
Not web surfing.
Not web surfing, definitely not real surfing with like feet sometimes on the board. This takes me to one of our episodes, Anti-Cancer Molecules, which was recorded live on the West Coast. Our guest, Dr. Bradley Moore from the Scripps Institute of Oceanography, had a brilliant view of the waves.
And it is always fun to actually look in the eyes of your interview subject and be in the same room. So you and I were already on a work-related trip, and that allowed me to visit Dr. Moore at his oceanfront office in San Diego. He told me about his use of marine microbes to fight aggressive cancers such as glioblastoma.
I guess when I look out my window here and I gaze out at the Pacific Ocean, I see endless possibilities of life that is evolved to our planet and the environments that it lives. For millennia, you know, humankind has been taking inspiration of nature to cure our diseases. You can think back to, you know, aspirin coming from a bark of a willow tree and these things. So that isn't new. What is new are two things. One of those things is the ability to sequence genomes of organisms and do it fast and do it cheaply. And this has now unearthed this ability for us to read the sequence of a genome, a whole bunch of A, T, G's, and C's, this letter code, and realize that these letters mean that they code for chemistry, and they code for how molecules are born in organisms. And this then gives us a recipe that allows us to take those sequences and then convert them into evolved chemicals that have a purpose, and they can actually connect to a receptor or to a protein to turn it on, turn it off, and that's what medicine does. So that's one thing that has really changed. It allows us to really take the sequence of DNA and convert it to chemical or to medicines. The second thing, it really allows us to look at organisms that do this, which is pretty much every organism on planet Earth. Even the gnarliest insects that freak you out, they've got a beauty to their DNA. And allows us to find organisms that are rare, hard to get at, and I just need a smidgen of that organism just to get its DNA, and it allows me then to read it and to make medicine.
For my final favorite of the year, I found our first episode of our patient-derived organoids series. And this was a series on organoids, little 3D biological microtissues that contain multiple types of cells. And our guide was Oksana Sirenko from Molecular Devices. You can trigger development of stem cells, which, long story short, trigger the development of cardiac tissue, and they take on a resemblance of cardiac chambers. And they even start to beat in the culture.
And that's epic when you see that, isn't it? It's just extraordinary, these beating cells in a dish. And that means that if you test the effect of a disease or drug on those cardiac tissues, you get a much more accurate read as it's mimicking the effect on normal cardiac patterns.
Precisely. And this form of testing is super important because, as you know, Connor, just 3% of new drugs make it to the clinic. So 2D cell models or animal models are just not good enough anymore to represent real biology in real tissues.
So that makes me ask a question. What's holding us back from using patient-derived organoids as the only way for testing drugs and treating diseases?
So biology is very kind of powerful technology. Any power technology, whether it's genetic medicine, whether it's artificial intelligence, it has some dangers that it could be misused or kind of improperly used. But there are regulation in place for using materials to treat diseases. They needs to be FDA approved. And also there are also the regulation around induced pluripotent stem cells or stem cell technologies. So I believe that limitation actually sufficient to make sure that it will be appropriately used. But I believe as technology evolved, probably new regulation needed to be in place, especially when it's potential treatment of a real patient would be involved.
So that's lovely. Why was that a favorite, Dodi?
You know, sometimes our interviewees come up with incredible work that doesn't even enter my sphere of reality until we speak to them. So Oksana really introduced something way out there that I enjoyed hearing about. You know, and Molecular Devices is actually a sister company of ours within the Danaher Corporation. And I walked away from this episode thinking, gosh, we have amazing neighbors, and what incredible potential there is to make a positive impact on human health.
Getting all teary-eyed, are you? Putting together this bi-weekly podcast does involve a few members of the team. Yes. So how about Beth, our editorial producer? Does she have a favorite?
In the summer, Dodi and Conor were joined by John Morris, a scientist at the forefront of cryopreservation technology. They discussed cryopreservation's impact on CAR-T therapies and the development of therapies, why freezing cells is essential to these treatments, and how tracking these samples ensures the quality, which of course is really important for patients, and the potential for frozen cells to treat solid tumors in the future.
The CAR-T workflow at the moment is that you take cells from a patient, you freeze them, you ship them to a manufacturer, the manufacturer grows the CAR-Ts up, we then freeze them, ship them back to a patient. And this can be in different continents. And it's critical to be able to just ensure that the right cells are coming back and there's no mixing up. And we've been instrumental in developing a cold chain with equipment and software so that we can ensure the sample's followed at every stage, and also that the sample you can check it's been frozen correctly.
Also, you can check that it's been thawed correctly and stored correctly. This ensures that the patient is going to get the best quality material for treatment. So there was a need for cryopreservation to help scale up.
And John's vision exactly when he set out to create a cryogenic cold chain, doesn't that just sound cool?
Absolutely.
I work in cryogenic cold chains.
Cold chains.
That's a real conversation starter in the pub, isn't it? What was his vision when he set out creating these?
The vision was basically to be able to just digitally track, the sample from the patient right the way through the manufacturing process and back into the patient, and to know it was optimum for treatment.
And if we look back now at all that's been achieved and all of John's contributions, they've been absolutely foundational here. If it weren't for the cryo cold chain, then the potential of CAR-T therapy may not have happened for another 10 years.
Isn't that great to hear Beth's voice for real?
Exactly. Doesn't she sound magic? We should get her on more often, I think.
Yeah.
Thank you, Beth.
Now it is time to do Every Day is a School Day for the last time this year. And this is, maybe it's depressing or maybe it helps you kind of let go at the end of the year. But this is an article from phys.org. phys.org, always a good place to spend 5 or 10 minutes just thinking about crazy things. So researchers are now proposing that we are living in a giant void in space. So the Milky Way galaxy near the center of a void about 1 billion light years in radius with a density 20% lower than the average of the universe as a whole. What does that tell us? It maybe answers questions about how the universe began, maybe how it will end, but it's kind of crazy. And it reminds me of a conversation we had on one of our earlier episodes in an earlier season about maybe we're all living in a big simulation. It's a big simulation in a big old giant void.
Okay, now I just feel really, really tiny, small, and totally insignificant. Yes. So, in a related study, believe it or not, what I have pulled up this week is that Earth-like planets could form even in the harshest environments, according to a study published by Penn State. So they've discovered that Earth-like planets, including planets with water, which may be a precursor to life, could form even in the harshest known planet-forming environments.
Like giant voids.
That would be a giant void. So it's not all hopeless, right? They used the James Webb Space Telescope and they looked at disks of gas and dust where planets form within a rich stellar nursery about 5,500 light years away, which is like a long way and probably quite, a hostile environment. And they specifically looked at disks located around stars similar to the mass of the Earth's sun. And they found that it's quite possible that Earth-like planets could form in these environments. So there might be someone else out there. Can we leave it at that?
Let's leave it at that. And I'll tell you then that the executive producer of Discovery Matters is Bethany Grace Armitt Brewster. Editing, mixing, and music by Tom Henley and Banda Productions. I've been Dodi Axelson with you during 2023.
And for the most of 2023, I have also been Conor McKechnie, except for a short time in August when I was someone else. Make sure you rate us on Spotify or whichever platform you use. We'll see you when we come back next year with another episode of Discovery Matters.